The first algorithm we are going to discuss is the brute force algorithm. Now, the brute force algorithm is done in 3 steps. In step 1, we make a list of all the possible Hamilton circuits of the graph. Now, our starting vertex is going to be A. Now, if we find every single possible Hamilton circuit starting at A and we list all of the options, in essence, we found every single possible Hamilton circuit in the graph. Because if we listed all the Hamilton circuits starting at B, what they would be is they would actually be the same circuits as the one starting at A. It's just the reference point or the starting vertex would be different. And the same is true if we listed all of the circuits starting at C and if we listed all of the circuits starting at D. They would be all of the same circuits that we would have found at A. The only difference would be the reference point. So in essence, if we find all of the circuits starting in A, we have found every single possible Hamilton circuit in this particular graph. So this is a complete graph. It's a K4 because there are 4 vertices and every vertex is connected to every other one. So first step, make a list of all the possible Hamilton circuits of the graph. The second step is to calculate the total cost for each circuit. And then the last step is choose an optimal circuit with the least amount of cost. Since every single Hamilton circuit is possible, we can come up with the optimal circuit. So that's what we're going to be looking for. So let's just go ahead and get started with this brute force algorithm. Now what I like to do is I like to do little pictorials on the side. I'm a visual person. It helps me to see what's going on. So I'm going to be starting at A. Now when we go from A, we could go to B, we could go to C, we could go from A to B, A to C, or A to D. I like to keep things alphabetical. So let's list all of the options going to B first. So my first circuit's going to be from A to B. A to B has a weight of 200. From B, I have 2 options. I can either go to C or I can go to D. Let's go ahead and keep it alphabetical and go to C. From B to C is 140. Now from C, I have to go to D. From C to D is 160. And then from D, it will be time to go home. So that is what my first circuit looks like. And from D to A is 60. And the total of this is 560. So let's move on. That is the first circuit. So we want to stay with going from, starting at A again, going to B. Because in this one we went A, B, C first. Now in this example, let's go A, B, D. So A, B, what was that? A to B is 200. And then this time we're going to go to D. From B to D is 70. Now you can see the only vertex we have left to go to is C. We have to travel to C. From D to C, that's 160. We've traveled to every vertice. Now it's time to go home, back to A for 210. Now the total cost of that circuit is 640, and you can see what that looks like. Okay. Now we have exhausted all of the possible solutions going from A to B. We started with A to B and went to C, and then we went A to B and then went to D. There are no other options going with A to B. So now we're done with A to B. Let's go. The next one in alphabetical order would be A to C. Now from A to C, starting that leg first, which is 210, we have 2 options again. We can go to B or we can go to D. How about let's go to B first, and then on the next one we'll go to D. So A to C is 210, and then we're going to go to B. From C to B, it's 140. From B, we have to go to D. From B to D, it is 70. We've been to every vertice. Now it's time to go home, back to A. From D to A is 60. And that is for a total of 480. Okay, the next Hamilton circuit, we're going to stay with going from A to C first. So A to C, that was 210. We went to B last time. Let's go to D this time. From C to D, it is 160. Now it's time to go to B. D to B is 70. And then it's time to go home to A. And A is 200. If we add up all those numbers, the cost of that is $640. Okay, we've exhausted all of the options going to A to C first. A to C to B, A to C to D. There is nowhere else to go with A to C. So now we're going to go, the first leg is going to be A to D. So A to D, that is 60. And we have two options again. We can go to B or we can go to C. Let's keep it alphabetical and go to B. So from D to B is 70. Then we are going to go to C, which is 140. From C, we've been to every vertice. Now it's time to go home to A. C to A is 210, and that is a total of 480. Okay, the last one that we have is keeping with A to D, which is 60. We went to B up here, so now we're going to go to C. From D to C, that is 160. From C, we're going to go to B. That is 140. And from B to back to A, which is 200, and the total cost there is $560. Now, if we analyze all of the circuits, we have every single possible Hamilton circuit listed starting at A. We've calculated the total cost. Now we just have to choose the optimal. And if you can see here, we have 2 at 480. And if you look at their pictures, you can see that the Hamilton circuits are exactly the same. They're exactly the same circuit. All that they are, if you look A, C, B, D, A, is they are mirror images of each other. And if you see, we've also found a couple other mirror images. This one, the first one, and the last one. If you look at the pictures, those are mirror images, A, B, C, D, A, and also the ones at 640. The picture is identical, and they are just mirror images of each other. So our optimal one, it's pretty obvious, is right here. I'm going to go ahead and write down the answer, A, C, B, D, A, along with the mirror image, A, D, B, C, A. A, D, B, C, A, for a weight of 480. That would be the answer using the brute force algorithm.